Now, geometry. This is Geometry Notes 1.4, and we're pretty much going to mirror what happened in class with Notes 1.3 or on the video in Notes 1.3. So we're looking at angles today, and you'll be working with angle addition postulate, angle bisector ideas, and we'll talk about the congruence and equality of angles and how they're related to the segments. Okay, the definition today we're looking at is an angle is formed by two rays with the same endpoint. Okay, the rays are the sides of the angles, and the endpoint is the vertex of the angle. Now, how would you name it? You name the angle by its vertex, angle A point on each ray in the vertex. So I could say this is angle BAC, or angle CAB, or angle 1 if I put numbers inside, but generally if it's the only angle, I would just use one letter and call it angle A. Or I could use, again, the number 1 to name the angle. Now remember, the sides of the angle have a common endpoint, A, in this case, so we have ray AB and AC as the sides of the angle, and the vertex is A. Now you have the interior and exterior parts of the angle. Okay, the interior of an angle is a region containing all the points between the two sides of the angle. So all the points between the two sides of the angle is this green interior section. The exterior of an angle is the region containing all the points outside of the angle. So now if I'm looking at 1A, B, and C, I can talk about interior and exterior of the angle. The interior is the inside. It's the part of the angle that's less than 180 degrees is the interior side, and the exterior is the other stuff. So in B, it's interior and exterior there. I won't talk about the interior and exterior of the angle in C because there are three different angles there that we could talk about. For the angles above, we labeled the exterior parts of angle A, 1A and 1B. Now what I want you to do is, in 1A, list the vertex of each angle. Okay, so the vertex in A is A itself. The sides of each of the angles in 1A, the sides are ray AB and ray AC, and we have ray AB and ray AC. The names, the different names we can give to the angles: angle BAC and angle CAB with the vertex of the angle as the center portion of the name, or the vertex of the angle as the only part of the name, and we also can name it angle 1. What I'd like you to do is turn off the tape and list the same information for 1B, the vertex of the angle, sides of each angle, and give the names of each angle. Okay, welcome back. Hopefully that went well. And you have the vertex be E, the sides are ray ED and ray EF, and the names are angle DEF, angle FED, angle E, and angle 2. And in the last one, we have several angles going on, so I'm going to talk about several things going on with it. We have a vertex, which is H, but the sides of the angle, depending on which one we're talking about, we have different ones. So the sides of HK and HG is talking about this angle 3. So angle KHG or angle GHK or angle 3. The sides of HG and HJ are angle GHJ or angle JHG or angle 4. And the last one, the larger angle, the sides are HK, ray HK, and ray HJ. And the angle names are angle KHJ or angle JHK. Now the types of angles. We have acute, right, obtuse, and straight. Acute angles are between 0 and 90 degrees, not including 90. Right angles are always 90. Obtuse angles are between 90 and 180. And straight angles are exactly 180. Now the measuring of a angle COD here is the absolute value of the difference of the real numbers paired with point C here with ray OC. I've got AOC with my point C and point D with ray OD. Keep in mind, this is a lot like the stuff that we did yesterday in working with the absolute value of the length of a segment. Now we're just talking about that length of the opening of our angle. And if I got this at at C and D, I can subtract their difference and be able to come up. But be careful to use the correct numbering system. If you pull your numbers from the bottom, then pull your number from the bottom. If you pull it from the top one, pull it from the top one. Do not mix and match the two different number systems you have. This is 0 to 180. This is going left to right. And this is 0 to 180 going, I suppose, counterclockwise. And the other one's clockwise. So what I want you to do is find the measures of each angle and classify each angle as an acute, right, or straight. My example, LKN. LKN, if I use the numbering system, 0 up to 145, I'm using the bottom number system. So I got a 145 degree angle, and it's obtuse because it's greater than 90 degrees. And it's between 180 and 90. Go ahead and list the remainder, and then turn back on the tape to check your work. In B, LKH, I use the top number system, and I go 0 to 35, so it's 35 degrees, and it's acute. In C, I got JKL, so remember, K is the center, and JKL, and I start at 35 and go to 90. That's 10, 20, 30, 40, 55 degrees, but I could have gone 90 minus 35 and found 55 degrees. HKN, the measure of HKN is a straight angle, 180 degrees. JKN is a right angle, it's 90 degrees. And MKH, I use the top numbering system, 0 to 145 again. So I got 145 degrees, and it is obtuse as well as number 2A. Now, with a protractor, we want you to measure, and when you have your protractor, you're able to position the protractor in such a way that you can move it right on top of the angle. So here, in this one provided, I'm going to adjust my angle and my protractor. It's about 90 degrees. It might be a little bit more, but we're going to be within 2 degrees. It's right and it's 90 degrees. I'm just going to slide my protractor along. And remember, the numbering system I'm going to use, I'll bring this into the picture better. There we go, we have it positioned better. I've used the bottom number system. I'm going all the way up to about 128 degrees, which is obtuse. Now the next one, I'm using the bottom number system again, from 0 all the way up. Looks like I'm going to be about 53, 54 degrees. And that is acute. So remember, as you're positioning your protractor, keep in mind, do your best with positioning. We're going to grade them within 2 units, but more than likely it'll be much like problem 2 when we're doing the quiz or a test, so that you don't have to guess how to place a protractor. Now, angles with the same measure are congruent angles. Please notice the tick marks. Yesterday, or the day before, in section 1.3, we had tick marks in the center. Here we'll have tick marks along the between the 2 rays provided. So if measure of angle A and measure of angle B are equal, notice how I'm reading that, and we have measures. This represents numbers for angles. The measure of angle A is equal to the measure of angle B. So I have an actual measurement, an angle measurement in degree. And then, if I'm talking about congruence, angle A is congruent to angle B. Well, I can write angle A, if angle A is congruent to angle B, then the measure of angle A is equal to the measure of angle B. So keep in mind, if I have congruent angles, the measures are the same. If I have the measures of 2 angles the same, then I can say they're congruent. You mark the angles with arcs to show that they are congruent. If there is more than one set of congruent angles, each set is marked with the same number of arcs. So consequently, since angle A and angle B had single set marks, I could have another set mark here, which is a double set mark, and be implying that these 2 angles here are congruent based on the markings that go across the arc between the 2 rays. Now, use the diagram to list the pair of congruent angles. So BAJ, angle BAJ, is a single arc angle. Another single arc angle is angle DFE. So I just write that in, angle DFE. So DHG, angle DHG is a double arc angle. I find another double arc angle, which angle CBJ. And angle FJH, angle FJH is a triple arc angle, and another triple arc, incidentally it's a vertical angle, is angle AJB. And those angles were determined directly from the markings that were provided. Now, just like we did segment addition postulate, we have angle addition postulate where the angles that are being added together share a common ray. Angle AOB and angle BOC can be added together to be the same measure as AOC, but we'll use an M in front of each. This is the variable. Measure of angle AOB represents a number. The measure of angle BOC represents a number. And this measure of angle AOC are those two numbers added together. So to emphasize what we're doing, I have two angles I'm going to add together. I have angle RQT is 155 degrees. I have angle RQS and angle SQT, and I'm going to represent them as the measure of RQT, or angle RQT, is equal to the measure of angle RQS plus the measure of angle SQT. So I can talk about it just like I did with segment addition postulate. Remember, these represent variable values. Very descriptive, the variable values of an angle. So I know the measure of angle RQT is 155 degrees. Measure of angle RQS is 4x minus 20. And the measure of angle SQT is 3x plus 14. I get the combined like terms. And 155 is equal to 7x minus 6. And now I just solve for x. And I find out that x is 23. Again, once you find that x is a value, reread the question and make sure that's what you're supposed to find. In this case, I was supposed to find the measure of angle RQS or the measure of angle TQS. Well, I plug 23 in for x at 4x. 4 times 23 minus 20. Okay, and that's going to give me 72. Okay, and then to check out the other angle, I put in 3 times 23, which is 69, plus 14, excuse me, times 23, which happens to be 69, plus 14, which happens to be 83. So my final answers will be 72 degrees and 83 degrees for my angle values. It's your turn to try, but I'm going to do this with you because I haven't talked about a straight angle. Angle DEF is a straight angle. That means it's 180 degrees. So what are the measures of angle DEC and the measure of CEF? So I know from the get-go that the measure of angle DEF is equal to the measure of angle DEC, which is added together with the measure of angle CEF. So again, these are angle values, okay? And I know a straight angle is 180 degrees. That's what the measure of DEF is. And these others, 11x minus 12 and 2x plus 10, are values of the other two angles. At this point, after I set up, I get to combine like terms and solve. So I get 13x minus 2, and I got to add 2, so I got 182 equals 13x. Dividing by 13, I get 14. Now, again, I'm asked to find the measure of DEC and the measure of CEF. So the measure of DEC, 11 times 14 minus 12 is 142. The measure of DEF, or the measure of CEF, excuse me, the measure of CEF is 2 times 14 plus 10, which is 38. Not necessarily drawn to scale, but I'm able to show how I achieved my answer and check my work. Okay, and that's our notes for today. I hope everything went well. If you have any questions, let's ask the next time you're in class.